Hello everyone. Today in this session we are going to discuss regarding the water distribution system. In earlier session we have discussed regarding the storage reservoirs, their types. Today also will some part we will revise of the storage reservoir. So in today's session methods of water distribution system and also distribution pattern, these 2 points we are going to see. After distribution, after disinfection of the water, water is stored in the reservoir and it is supplied to the consumers. But there are also various methods of the distribution by which this water is supplied to the consumers. So we are today we are going to see how it is distributed to the consumers, what are the various methods. So overall content of the today's this session will be layout of the distribution networks, methods of water distribution, storage capacity of the ESR, elevated service reservoir, and also underground service reservoir. Now, the purpose of distribution system is to deliver water to consumer with appropriate quality, quantity and pressure. Distribution system is used to describe collectively the facilities used to supply water from its source to the point of usage. Requirements of good distribution system. Water quality should not get deteriorated in the distribution pipes. It should be capable of supplying water at all intended places with sufficient pressure head. It should be capable of supplying the requisite amount of water during firefighting. The layout should be such that no consumer would be without water supply during the repair of any section of the system. All the distribution pipes should be preferably laid 1 meter away or above the sewer lines. It should be fairly watertight as to keep the losses due to leakage to the minimum. Layouts of distribution network. The distribution pipes are generally laid below the road pavements and such their layouts generally follow the layout of roads. There are in general 4 different types of pipe networks, any of which either singly or in combination can be used for a particular place. So in that layout of distribution network, 4 types are available: dead end system, radial system, gridiron system, ring system. Dead end system. It is suitable for old towns and cities having no definite pattern of roads. Now you can see this dead end or the tree system, they are follow the roads which are available, right? So here if you see this M alphabet stands for the main pipelines. Okay, then this S stands for the sub-mains. Sub-main pipelines are there, and these are the B stands for the branches. So there is no such a typical pattern. Okay, these are totally dependent on how the roads are available there. So accordingly, that's why it is called as a tree system, because it is similar to the branches of a tree, right? So that's why it is called as a tree system as well. So when there is no definite pattern of the roads available, so in that situation this dead end or a tree system is used. Now what are the advantages of this dead end system or tree system, it is a relatively cheap method of distribution. Determination of the discharges and pressure easier due to less number of walls. Disadvantages: due to many dead ends, stagnation of water occurs in the pipes. So as a tree system we are providing, there are number of dead ends are there. You can observe here, these are nothing but the dead ends are there. Okay, so that's why there is a stagnation of water may occur at the various pipes. Now next one is the radial system. The area is divided into different zones. The water is pumped into the distribution reservoir kept in the middle of the zone. The supply pipes are laid radially ending towards the periphery. Now you can see the radial method how system is there. This is the main pipeline is there, right? And from a typical distribution point, these are the branches which are acting as a radial lines. Okay, similar pattern can be observed in this part as well. So as these are showing a radial ray pattern there, that's why it is called as a radial system. Now what are advantages? It gives quick service to the consumers. Calculation of the pipe sizes is easy. Then next one is a gridiron system. It is suitable for cities with rectangular layout where the water mains and the branches are laid in rectangles. When a typical pattern of the roads is present, so in such cases gridiron system can be used, and especially as the first statement is there, suitable the cities with the rectangular layout. It is, you can see here the main pipeline is there, right, and transverse to that you can find the branches. So this sub-mains, and sub-mains are associated with the branches. So again you can see these black dots are here. These black dots are nothing but the cut-off walls are there. So these are the control walls are there which can control the flow of water or distribution of water in that particular area. So there are various advantages and disadvantages of this method as well. So what are the advantages? Water is kept in a good circulation due to absence of dead ends. In the cases of a breakdown in some section, water is available made from some other direction. So what is the meaning of the second statement? That if because of some reason, suppose this particular pipeline get damaged in this area, so what we can do, we can provide the water from the other pipelines to that particular area. That is the main advantages of this system. So what is the disadvantages? Exact calculation of sizes and pipes is not possible due to provision of walls on all branches. So it is a critical one to calculate all sizes of pipes, and but it can be calculated, but it takes a time to because of the number of walls which are present. Ring system. The supply main is laid all along the peripheral roads and sub-main branch out from the mains. This system also follows the gridiron system with the flow pattern similar in character to that of dead end system. So determination of size of pipes is easy. Now what are the advantages? Also you can see water can be supplied to any point from at least two directions. So you can see how why it is called as a radial system, you can say, because, or it is also called, you can see here, why it is called as a ring system, because it follows that pattern, So the main pipe is provided here, right, and you can, this surrounding as a simply like a ring, it is main pipeline is, it is totally following the periphery of that area, and sub mains are there here, and probably again to sub mains these branches will be there in between the various sectors. So this picture seems to be small here, but for a large city, you can say, so this may be a single ward, you can see, this may be a single ward here. Okay, so remember like that. So these are the cut-off walls are there, or control walls are there, right, which are provided here. Now we'll go for the next part of this, methods of water distribution. For efficient distribution system, adequate water pressure required at various points. Depending upon the level of source, topography of the area and other local conditions of the water may be forced into distribution system by the various ways. Now as you know that the tap water which is received at our end, it is having some pressure, right, and it's because of that the design which is carried out in the water supply system. Now what is generally done in the various now in cities, if you see, mostly if you have observed, so in the cities, in the various localities or the various wards, you can say, so elevated service reservoirs are present, right. So what from the water supply plant, by using the pumping system, the water is stored in these elevated service reservoirs, and then by using the gravity method from this elevated service reservoir, the water is supplied to that particular area or that particular ward, right. So this is the one system which is present, which is called as a combined system. But sometimes the locality or the topography is available such that the location of the tank, or can the storage reservoir, it is at the top position, and the area to be supplied, it is at the lower elevation. So the in that case the water can be supplied directly without any pumping action there. So by gravity we can supply the water to the consumers. But sometimes it also happens that the area to be served is at the higher elevation, right. So it is necessary that to provide the water to the consumers by using some a pressure, and that can be applied by using the pumping system. The pumps are provided, and by using the pumping system, the water is provided to the consumers. So let's have the one glance on this type of water distribution system. So methods of water distribution, one is a gravity system, pumping system, combined gravity or pumping system, it is also called as a dual system. Now in the gravity system, it is suitable when source of supply is at sufficient height. It is the most reliable and economical distribution system. The water head available at the consumer is just minimum required. The remaining head is consumed in the frictional and other losses. So you can see after the treatment of the water, after the disinfection method, the water is stored at this particular position in this tank, right. Then the area to be served on a lower elevation. Now it is quite possible that we can provide the area by this particular area, the water can be provided by using the gravity system. So This is the advantage of this system, you can say. Next one is a pumping system. Treated water is directly pumped to the distribution main without storing, also called pumping without storage system. High lift pumps are required. If power supply fails, complete stoppage of water supply that takes place. This method is not generally used. Okay, this is in a very rare situation the pumping method is used. So what is the configuration of this system? You can see from the water treatment plant, the water is stored in one of the storage tank, and this is the uh, pump connection provided to the pump, and the pump is uh, supplying, or you can say it is providing the water to the consumer which are at the higher elevation. Okay, so this situation arises in the very rare type of supply. The main disadvantage is that with the in the case of the power supply, this total system that gets stuck, because without power supply you cannot supply the water to the this higher elevation. Next one is a combined gravity and pumping system. It is the most common system, as I explained earlier. Treated water is pumped and stored in an elevated distribution reservoir, then supplies to the consumer by action of gravity. The excess water during low demand periods gets stored in the reservoir and gets supplied during high demand period. Economical, efficient and reliable system. Now you can see here in this case, as I told earlier, from the water treatment plant, the water is taken to the storage, right? Storage tank is there, and from the storage tank, by using the pump, the water is supplied to the service reservoir, elevated service reservoir. Now this may be present in the various wards, as I told, that in the various localities in the cities, and then by using the gravity method it is supplied to the various part of that area, right? Next, that let's have the glance or the revise the regarding the distribution reservoirs. As we have seen the various types of distribution reservoir, especially I am repeating this part because there is types of distribution reservoir that we have seen, right? But on type of material also there is some classification. Now let's have the revision on this. Distribution reservoirs, also called as a service reservoirs, are the storage reservoirs which store the treated water for supplying water during emergencies, such as during fires, repairs, and also helps in absorbing the hourly fluctuation in the normal water demand. Now, what are the functions of the distribution reservoirs? To absorb the hourly variations in the demand. So throughout the day there is a lot of variation in the demand of water, so that can be compensated by the distribution reservoir. The main constant pressure in the distribution main, to maintain the constant pressure in the distribution main, water stored can be supplied during emergencies. Location and height of distribution reservoirs. So it should be located as close as possible to the center of demand. Water level in the reservoir must be sufficient at a sufficient elevation to permit gravity flow at an adequate pressure. Now types of reservoirs that we have seen, depending upon their elevation with respect to the ground, it may be classified into surface reservoirs, elevated reservoirs and standpipes. As we know that these are also called as a ground reservoirs as well. Now surface reservoirs, these are also called as a ground reservoir, mostly circular or rectangular tanks. Underground reservoirs are preferred, especially when the size is large. That's why I have especially repeated it today. So these underground reservoirs are preferred especially when the size is large, right? The these reservoirs are constructed on high natural grounds and usually made of stones, bricks, plain or reinforced cement concrete. Okay, and the inner surfaces of all these water tanks are water coated, of course. Water tight surfaces are there. Right, the sides of the wall designed to take up the pressure of the walls, and when the reservoir is full, and the earth pressure when it is empty. Remember, now two points we have to consider in the design also, that when the tank is full, the water pressure will act on these walls, and when the tank is empty, due to height of that reservoir, underground reservoir, the soil pressure or the earth pressure may act. Okay, in that case, the walls of this water treatment plant, they may be acting as a retaining wall, isn't it? So we have to plan or design accordingly. The position of the groundwater table is also considered while designing these reservoirs. If you are providing the groundwater reservoirs, we will also see the groundwater table where it is available. The floors of these reservoirs may be constructed with the RCC slab, square stone blocks resting on the columns. To obtain the water tightness, bitumen compounds are used at all construction joints. Okay, so it secures the, or you can make the secure against the leakages. At the top of roof, about 60 centimeter thick earth layer is deposited and maintained green lawns to protect the reservoir from cold and heat. For aeration of water and inspection, ventilator pipes and stairs are provided. That also we have seen. Now this is one example of a underground reservoir. So you can see these particular reservoirs are of the very great volume. You can see dimensions are very nice. So you can find out the ventilators are provided here. Okay, so at bottom and at top you can find out the concrete bed is there, concrete slab is there. So these walls, those may be of a masonry, or nowadays RCC also can be preferred, right? So in between, to support these columns may be provided, right? And this height may be more, and we'll have to take care when the water is more, water is full. Here we'll have to, water pressure will act on these walls, and when it is empty, what will happen? The earth pressure will act on this. So we have to take care of when we are designing the underground reservoirs. Now, before that, we have already seen the elevated service reservoir and the stand pipes, so that I am not repeating here. Then today we'll see regarding the types of tanks. Regarding this RCC tanks are more popular when they are having the long life, very little maintenance, and having a good appearance, decent appearance is there. Then galvanized iron tanks. GI tanks are generally in rectangular or square in shape. Nowadays GI tanks are not preferred because tank is short, corrosion of metal, and maintenance cost may be more. Then high density polyethylene HDPE tanks. Nowadays HDPE tanks are most popular for storing the less quantity of water, and hence useful for the residential purpose. This is not actually for use for the any main water supply treatment, but this is one of the choice available. What are the advantages of HDPE tanks? Handling is easy because of lightweight, cheap in cost, maintenance cost is low, cleaning of tanks is very easy. Now let's have the glance on the elevated service reservoir. We have seen this. Now this elevated service reservoir is also referred to as overhead tanks, which are required at the distribution area, so which are not governed and controlled by the gravity system of the distribution. These are rectangular, circular, or elliptical in the shape. if the topography of the town is not suitable for under gravity, the elevated tank or the reservoirs are used. They are constructed where combined gravity and the pumping system of the water distribution is adopted. These tanks are maybe of steel or RCC. Now the RCC is commonly preferred for construction of such tanks. The accessories of ESR are the inlet and outlet pipe, this that we have discussed. I will fastly go through this. Overflow pipe discharging into the drain, float gauge indicating depth of the water, automatic device to stop pumping when the tank is full, a manhole and ladder, ventilator and the circulation of the fresh air. Here also the float gauges may be provided with the automated system. You can see here this is the pumping system. This elevated service reservoir is there. So I got this particular cross section, that's why I'm repeating this. So this is the inlet pipe, okay, which stores the water in this elevated service reservoir, and this is the distribution pipe, okay, outlet pipe. This is the serving area, right? So this is the indicator pipe is provided here, and also this some automated system can be provided, right? Storage capacity of the distribution reservoir, that also we have seen which factors affect the storage capacity. The total storage capacity of distribution reservoir is a summation of the balancing storage, the quantity of water required to be stored in the reservoir for equalizing or balancing fluctuating demand against constant supply is known as the balancing storage, or equalizing or operating storage. Breakdown storage, the breakdown storage, or often called as the emergency storage, is a storage preserved in order to tide over the emergencies posed by the failure of pumps, electricity and any other mechanism driving the pumps. Value of about 25% of the total storage capacity of reservoirs, or 1.5 to 2 times of the average hourly supply, may be considered as enough provision for the accounting this storage. Fire storage, the third component of the total reservoir storage is the fire storage. This also we have discussed. This provision takes care of the requirement of water for extinguishing the fires. Now here provision of the 1 to 4% of the per person per day is sufficient to meet the requirement. Now important to remember the equation that when reserve storage is elevated, amount of fire reserve may be determined by equation R is equal to, in bracket, F minus P multiplied by D, where R is the reserve storage in liters, F is the fire demand liters per minute, P is the reserve fire pumping capacity liters per minute, and T is the duration of the fire in minutes. So remember this equation. The total reservoir storage can be finally worked out by adding all three storages. So today we have come to the end of this session. So especially today we have discussed regarding the various distribution patterns, distribution systems, and also types of service reservoirs or the reservoirs based on the materials as well, and also revised some part of the this storage system and calculation of the storage, and also especially today we have seen also how this reserve storages of elevated amount of fire reserve can be calculated. So thank you very much for joining this session.